Good morning, students. Chapter 7, System of Particles and Rotational Motion. Okay, see, here it is. Today we will see two most important theorems, parallel axis theorem and perpendicular axis theorem. Parallel axis theorem and perpendicular axis theorem. These two most important theorems of this chapter. But before that, we have to see another point, that is, if it is one body, it is its center of mass and it is axis passing from center of mass, and object is rotating about this axis. Okay, simple. This axis is passing from its center of mass, and object is rotating about this axis. Then moment of inertia about this axis, which is passing from center of mass, it is indicated by IC. Moment of inertia about an axis passing from center of mass of object is indicated by IC, C means center of mass. Clear? So what is IC? IC is moment of inertia about an axis passing from center of mass of object, and it is indicated by IC. Okay? For symmetrical objects, value of IC is fixed. For symmetrical objects, value of IC is fixed. Okay? Now we will see two theorems. See, first of all, parallel axis theorem. Parallel axis theorem. What is parallel axis theorem? What is parallel axis theorem? See, if I have one disc like this, because it is one disc. Okay? Yes, it is one disc like this. For example, okay, it is its center of mass. It is center of mass. So, moment of inertia about an axis passing from this center of mass, okay, is indicated by IC. But if now I am taking another axis, for example this axis, okay, then what is moment of inertia about this axis? If distance between these two parallel axes is d. Why it is named the parallel axis theorem? Because these two axes are parallel to each other. Clear? Okay? Okay. It is axis passing from center of mass. It is another axis which is parallel to this axis. Then how to find moment of inertia about this given axis? See, first of all I will write equation. Because from equation you can easily write its statement. That is, this I, moment of inertia about given axis. Moment of inertia about given axis. Moment of inertia about given axis. I is equal to IC plus md square. IC, moment of inertia about an axis passing from center of mass. M, what is M? M is total mass of body. M is total mass of body. And what is D? D is distance between two parallel axes. Distance between two parallel axes. Okay, so yes, you have to remember this equation. I is equal to IC plus md square. How to write its statement? See, moment of inertia about any axis any axis about this. It is angular. Okay, moment of inertia about this axis is equal to this is equal to, okay, moment of inertia about any axis is equal to sum of what is IC? IC is moment of inertia about axis passing from center of mass, and product of total mass of object, and square of distance between two parallel axes, okay. It is statement of parallel axis theorem. Yes, equation is easy. See, I is equal to IC plus MT square. With the help of this equation, you can make this statement. Moment of inertia about an axis is equal to sum of moment of inertia about an axis passing from its center of mass and product of total mass and square of distance between two parallel axes. Simple. Yes or no? So yes, it is parallel axis theorem. Yes, how to use parallel axis theorem? What is used? That we will see by taking numbers of examples. Okay. Now we will see what is perpendicular axis theorem. Okay. See, here it is. Now perpendicular axis theorem. See, what is perpendicular axis theorem? Perpendicular axis theorem. Yes, but this perpendicular axis theorem is applicable to planar bodies. It is applicable to planar bodies. How? For example, planar bodies means disk is one planar body. This board is one planar body. Okay, having plane means object lies in plane, 2 dimension. Okay, so yes, if I am taking one planar body, for example, I have one disk like this. It is one disk like this. Okay, yes, it is one disk. This disk, if it lies in xy plane, and z-axis is perpendicular to it. For example, see like this. If it is disk, okay, it is x-axis. This y-axis is perpendicular outside. Hello, this y-axis is actually perpendicular outside. Simple. Yes or no? Okay. If it is disk, it is x-axis, it is y-axis, and z-axis is perpendicular to it. Clear? Okay. So yes, here planar body lies in xy plane. Okay, here disk is in xy plane. This is in xy plane, and z-axis is perpendicular to body. Z-axis is perpendicular to body. Then see, first of all I will write equation. Okay, what is equation? Then after equation you can easily make what is statement. Okay, see, this z-axis is perpendicular to object. This z-axis is perpendicular to object. So moment of inertia about an axis which is perpendicular to body, that is indicated by Iz, because here z-axis is perpendicular, is equal to Ix plus Iy. It is Ix plus Iy. Moment of inertia about an axis perpendicular to body, Iz, is equal to moment of inertia about an axis which is within the plane of body, plus moment of inertia about an axis which is again in the plane of body. But see, this x and y, they are perpendicular to each other. Then how to write statement? See, moment of inertia about an axis perpendicular to plane of body, okay. Which axis is perpendicular to plane of body? That is z. So Iz, moment of inertia about an axis perpendicular to plane of body is equal to sum of moment of inertia about perpendicular concurrent axis in the plane of body. So what is meaning of this? See, sum of moment of inertia about perpendicular concurrent axis. Perpendicular, this x and y, they are perpendicular to each other. Concurrent means in the same plane. Okay, so moment of inertia about an axis which is perpendicular to body is equal to sum of moment of inertia about axis perpendicular and concurrent in the plane of body. Clear? Simple. Now see, you can have another two cases. If object lies in xz plane, for example, if this disk is given in xz plane, if disk is given in xz plane, then what is equation for moment of inertia about an axis which is perpendicular to its plane? That you have to write in your comment box. Clear? For today, these two theorem, parallel axis theorem, perpendicular axis theorem, most MP question. Okay. For 2 mark parallel axis theorem, for 2 mark perpendicular axis theorem. So yes, it is one of the most important question of this chapter. Clear about this? Yes. Don't forget to write your answer in comment box. Okay. If this disk is in xz plane, then what is equation? For today, this is it. Now we will see some questions based on moment of inertia. We'll start our questions from some particles. Okay. See, find the moment of inertia of system about axis AB. Yes, this axis AB. These are 4 particles and mass 1 kg, 2 kg, 3 kg and 4 kg. Distances are also given. Okay. Yes. As there are 4 particles, what is equation of moment of inertia about an axis? Okay. So yes, moment of inertia about axis AB, IAB is equal to about axis AB. First of all, I will write equation. M1 R1 square, M2 R2 square, M3 R3 square plus M4 R4 square. Okay. Is equal. Now I have to put values. Yes, M1, M2, M3 and M4. What is value of M1? 1 kg. What is value of R1? 0. Why 0? Because see, this point 1 kg lies on axis. This point 1 kg lies on axis. So its perpendicular distance from axis is 0. Simple. See, this point is on axis, so its distance would be 0. Okay. M2, its mass is 2. Okay. What is perpendicular distance of this particle from axis? See, it is 2 meter. Means it is 2 square. Plus mass of third particle 3. What is perpendicular distance of this particle from axis? Hello. Whenever you find moment of inertia, you have to take distance from given axis. Okay. Yes, this axis. So from these axes, what is distance of 3 kg? 2 plus 20 is 4. So it is 4 square. Plus m4, it is 4. What is perpendicular distance? So yes, it is 2 plus 2 plus 2 means it is 6 square. Means it is 6 square. Clear about this? Now, yes, you can easily calculate this. It is 0. 2 square means it is 4. 3, 4 square means it is 16 plus 4, 6 square means it is 36. So now you can easily calculate this and your answer will be in kg meter square. Yes, what is your answer? You have to write in comment box. Clear about this? Okay, so yes, one easy question. But yes, R, distance means what? Distance, perpendicular distance from given axis. Next question, see. Find moment of inertia of system about axis passing from center and normal to plane. And see, from figure it is clear. Okay, you are given a square. You are given a square. Square of side R and having 4 particles. Hello. Yes, these are 4 particles. It is just its enlarged view. Okay, it is particle. Clear? So yes, I have 4 particles. Now, see. In question of moment of inertia, axis is important. Find moment of inertia of system about axis passing from center. So yes, it is center. Yes, it is center. And normal to plane. See, this square is in plane of board. So, perpendicular axis, normal axis is like this. So about this axis, you have to find, about this axis, you have to find what is moment of inertia. Clear? Again, there are 4 particles. So what is equation of moment of inertia? I is equal to m1 r1 square plus m2 r2 square plus m3 r3 square plus m4 r4 square. Yes or no? Yes, it is. Now see, m and m means all 4 particles having same mass, plus it is axis. So see, from this axis, distance of this corner, from this axis, distance of this corner, distance of this corner and distance of this corner, it is same. Huh? Yes, it is same. Okay, then how to write? See, if it is R1, it is R2, it is R3 and it is R4. Then how to find R1, R2, R3 and R4? With the help of Pythagoras Theorem. See, it is R. It is R. Yes or no? Then this diagonal, if it is R, it is R, this diagonal will become it is root 2R. Yes or no? Yes, with the help of Pythagoras Theorem, it will become root 2R. And I have to find only corner to center distance. So this distance, okay, this distance, it will become root 2r by 2. Means it is r upon, means it is r upon root 2. Clear? So yes, here from figure I can write r1 is equal to r2 is equal to r3 is equal to r4 is equal to it is r upon. Clear? Center to corner distance you can easily find with the help of Pythagoras Theorem. Okay? Yes. First of all, take this triangle r. So it will be diagonal will be root 2r and diagonals half it is corner to center distance. Okay? So it is r upon root 2. So now see, I is equal to, I can directly write 4 into mass of each particle is r and center to corner distance is r root 2 whole square. Why directly multiply by 4? Each and every particle having same mass and the distance from axis is also same. So yes, I is equal to it is 4m r square divided by root 2 square, it will be 2. So it is 2 here, 4, it is I is equal to 2m r square. It is 2m r square. So it is moment of inertia about this axis for the system of particles. Okay, again, as you have 4 particles, write this equation. For particles, this equation. Okay, masses are same. Center to corner distance, they are also same. According to Pythagoras Theorem, it is r upon root 2. Directly multiply by 4 because distance and mass, they are same. So yes, you will get your answer 4 mr square root 2 h square, it will be 2. So 2 into 2, so it is 2 mr square. Clear about this? So yes, it is one easy question based on moment of inertia. This is it for today.